Okay, everybody, welcome to Digit seminar series. So I'm Simon Ahmed Christensen. First of all, I should say we're sorry that this is not face-to-face, but that was a lot of railways and tube strikes to blame for that, and hopefully the next one will be. So just a very quick introduction to Digit Lab before we move to Gina, who is our main reason to be here. So thank you very much, Gina, for joining us. Digit Lab is a UKRI next stage digital economy research centre, and it's one of 6 centres that was funded by the EPSRC. We're a 5-year research programme where we are 1 year into the programme roughly, and we're working on digital technologies really to understand the growth, the impact and transformation with large organisations. We are around a triangle of productivity, sustainability and well-being. And as we move as a society and as a number of sort of initiatives and innovations through industry to a next generation of product services with digital technologies, everything from a smart collar to AR, VR, to drones, to data analytics, to understanding connected systems. This requires work and research. And the centre is really a partnership with industry and across academia. So it's across the University of East Anglia, Royal Holloway, Oxford Brookes and Exeter, who are the main leaders of the Digit Lab Centre. And we have where we hope that we can make a difference in creating use cases across a number of industries, loosely labelled as food and agriculture, construction and energy, prof tech and education, and to look at 5 different perspectives from technology testbeds to understanding the digital business models as digital technologies are adopted, the transformations that are needed in organizational systems and structures, and what the impact is, for example, on responsible leadership, understanding employee well-being, and looking at how we drive digital innovation in there. So as part of Digit Lab, we have a seminar series, and we've had 2 so far. So this is our 3rd. So we're really happy to be able to join it. So I'm going to move to introducing Gina, who's our 3rd speaker today. So Gina is, I'll just stop sharing my slides for a second, sorry. So first of all, Gina, thank you very, very much for being with us. And we're so sorry that we haven't got the opportunity to meet face to face. Gina is an executive director of the Minderoo Research Centre for Technology and Democracy at the University of Cambridge, but also a professor of technology and society at the University of Oxford. And she's written a number of books, including Venture Labour, Self-Tracking and Human-Centered Data Science in here. Her work focuses on rapid expansion of digital information environments from workers and workplaces and in our everyday lives. And you are also involved in strategic advisory councils of the ESRC, as well as international scientific committees in UK Trusted Autonomous Systems Programme. So we're really pleased to have you on board, Gina, and we are over to you for the next session. Thank you.
Thank you, and thank all of you for coming out or in today. It's truly lovely to be able to share my work with you and to be able to support the exciting things that you're doing in the Digit Lab. I have planned to talk for a little less than 40 minutes, and this is, as I share my screen, great, you should be seeing my slides. I'm going to just open this chat. Great, there's a hashtag that we're reminded, Digit Lab Seminars. And sometimes I put my handle there. I'll do this in the chat for everyone as well. It's @GNSC. Great, I'll keep my chat box open in case there's a problem. So again, thank you all. The work I'm going to present today is from my next book that I'm co-authoring with a civil engineering professor, Carrie Sterd-Stosic at the University of Washington. And it's really rare that we get to, as scholars, follow a big digital change over its course. We usually have to go in on a 5-year project, on a 3-year project, on a 1-year data gathering system. But Carrie and I were incredibly lucky to be able to be at the beginning of an industry-wide change, one that promised to be quite transformative and disruptive, and to follow that change through. So the context, the provocation, the provocation for our work. Sorry, let me just get you back. The provocation for our work is that when we write about these big stories of technological change, we often miss the stories about work, the work that it takes to get these changes brought about by digital technologies in place. And then the second kind of provocation is when we write about the future of work, we miss the key stories around agency, labor, and ongoing transformations. We write about digital transformation as a moment or as tied to a particular technology, and not necessarily as about the ongoing negotiations that happen around and with technology. The context of what we're looking at is this, a photograph from our field site, building information modeling, where how large-scale construction occurs has gone through an enormous digital change. The amount of work that it took to get this photograph to be possible for people on a construction site being able to look at a digital screen is truly nothing short of extraordinary, actually. And so part of what we're doing in the book is tracing the story of how this change happens. Now, we came into the field expecting to find one set of stories. And as a qualitative social science researcher, primarily trained in sociology, with a large remit in the study of digital technologies, particularly with respect to work and organizations, I was looking for change and resistance in workplaces. That's kind of my remit. That's the hat. That's my hard hat. That's the hat I went into this field site with. And what I saw was actually something quite different. That rather than a set of resistance to the technology that was widely predicted, there was a lot of collaborative work going on to try to make it fit and try to make it work. And so we were faced with this quandary. If this technology is supposedly so disruptive, what is this work going on around it? What does that mean? What's happening as people are trying to negotiate around making this new tool fit? So the context is a set of tools and technologies called building information modeling. These tools and technologies feed straight into the digital twin conversation, 4D construction that is happening. Those are two of the buzzwords of the moment. Our projects were buildings much like these on your screen, large, complex construction, a medical office building attached to a hospital that we call Hill Hospital, a mixed-use residential and retail space in a downtown core that we call downtown high-rise, and a complex laboratory building with advanced engineering capabilities in public site labs. So these three projects we followed in various components of and stages of their work and their story of bringing building information modeling out over a 10-year project. Now, we didn't enter the field thinking we were going to spend 10 years looking at this. The first four were a pilot project generously supported by the University of Washington and on our first US National Science Foundation grant. And in that, as you see on the left-hand side, that was primarily focused on what is happening with building information modeling. So we did ethnographic observations. We've closely followed 5 teams in the architecture, engineering, construction, and operations teams, so the AECO teams. We looked at 3 very large-scale projects over the course of that work. We did 125 national interviews in the United States. And then we traced and built 33 case studies of highly performing buildings, of what the American Institute of Architects awarded as Committee on the Environment award-winning cases. We did case studies of how BIM technologies were being developed in those case studies. We then took a second 3-year project. So in that, we looked through energy modeling specifically. So once these BIM models are built, they can then be used to build analysis for how new kinds of energy analyses can happen in the building. And that too, we followed 1 company, 3 specific energy modelers as they looked at multiple clients, and that represented 18 different building projects. We did 20 much more in-depth interviews, a smaller number of interviews, but much more in-depth, with a very highly specialized emerging environmental service that was being provided to clients. And in that, we do deep dive cases with 7 high-performing hospitals across the United States. So what's at stake? Well, for those of you who have not been following the changes in construction, we are moving from what people in the field on the left would call plans and specifications to the possibility and ability to do 3-dimensional renderings of buildings. So this changes how people can think through buildings and processes together. In some of the earlier papers that we publish out of this work, we talk about the changes in interpretive and cognitive flexibility. So interpretive flexibility, of course, being a term that we develop based on the work of Bowker and Starr and Griesmer, where objects are very useful in the coordination of people's work because they can layer on different kinds of interpretation of what it means. And so in building and in construction, drawings, sketches, things written on blue boards, things written quickly on clipboards, they can mean things in different moments. One thing, however, to remember in this particular industry is once documents become signed off or finalized, they end up with a legal and contractual set of obligations. So once we see something as documented as on the left, and once that's shared, it becomes a sort of pseudo contract, and sometimes a part of an actual formal contract between the different parties of what will be built. So what we're seeing on the right is a 3D rendering of the same building shown on the left, except here we see it in, how those of us who are not architects or engineers, here's how it looks much closer to how we would appear. Now, 3D design has been a part of all of these fields for at least 20 years. What's new is the ability for architects, engineers, and constructors to actually work together and share the files digitally. So they all have been working on 3D, the 3D kinds of 3D representations that we see on the right. But when it comes time to sharing that information with one another, they've been doing it in the 2D representations that we see on the left. This is a very new move that they're sharing digital files. So on the one hand, it's changing how people see and think through their work, how they see and think through the building. But what we're going to focus on for today's talk is the challenges of what it means to bring these different kinds of negotiations together around how they're sharing information. So here we see, this is the beginning of our field work. This is a photograph taken by someone in the field, someone in the industry. And this is how the kind of work has happened, even on these very large scale buildings until quite recently. That though we have the capacity to have digital models, these prints, these plans and specifications would be put on board, and there would be quite a bit of collaboration around what is to be built, what are the plans, how are they to be built. In a very specific kind of work that happens, mechanical, electrical, and plumbing coordination, along with other associated internal building systems, or MEP coordination. These plans would be layered upon one upon another. So the plans drawn by the electrical subcontractor would be layered on top of the plans drawn by the mechanical subcontractor to see where their systems may be or may not be coinciding in space. So this would involve 2 or more people standing over a light box, looking at where the drawings might possibly show that lines could potentially intersect, and then trying to figure out the different elevations that those lines are on. So is something running at 2 meters above the floor, or a meter down from the ceiling, or is it running half a meter down from the ceiling? There would be those kinds of negotiations. Where are these different building systems in space? And so here we see an MEP system on the right hand side, and the power and the excitement and the enthusiasm around these sets of technologies that we collectively refer to as BIM, they really enable new ways of seeing together. They really enable these new ways of seeing these things. So this very large blue section that we can see going through the bias, cutting across the image, the largest piece of blue would be an air handling duct, right? That would be where air conditioning and cooling is coming through the system. Those purple, dark purple would be done, those would be some kind of water or waste. The smaller purple would be conduit carrying electrical wire or other kinds of wire. So, this allows now the teams to see how these systems are fitting within usually very tightly coordinated spaces that are above the drop to ceilings. And if we were in your beautiful space in London, you would be looking up at the ceiling and you'd see that there's probably a drop ceiling that's hiding all of this stuff that most of us don't take for granted until it doesn't work on very hot days. So we discovered that, while we have new ways of showing this information, those ways of kind of looking at the documents together, looking at the plans and specifications together to plan things out, really hasn't changed. And there were new kinds of problems that could be identified automatically through digitizing and automating some of these processes, but it really required new kinds of ways of talking through and ways that the teams were not quite used to. So that's together in a couple of papers, we talk about that. The latest one is this 2019 paper, Innovation Through Practice, that I can give you the reference to if you are so inclined. So with that as our context, I want us to think through, in the rest of the talk, the kind of arc of the book, of these 3 mechanisms that we think are incredibly important for thinking about how we see technological change in industries. And those 3 processes of what we call negotiated adoption of technology are futuring work, negotiating practices, and rewriting institutions. And I'll take each one in turn. Taken together, we think that this is a model of showing what it takes to move from individual practices on the ground level in workplaces through to how the rules of the game that govern how industries function change or don't change in response to a new technology. So the first is futuring work, and we define futuring work as the set of activities and actions that both industry leaders, but people also, practitioners on the ground, develop for both visions and practices of a new technology. And so what we mean by this is the kind of prefiguring work that happens of how a new digital technology could be put into place, or what it's going to be. And for us, it was quite a bit of discussion that this new set of tools would do nothing less than save the industry. So from conferences to trainings to industry newsletters to magazine articles for the industry to discussions that we had with people, the tools were seen as a way to save a failing industry, that the industry needed to make some serious changes to improve productivity, and somehow this way of sharing documents and information would be the way to save it. This is going to save the industry. It goes so far to stage from a couple of industry leaders a great debate. So which way should this technology develop? Should it develop as one central database where everybody working on a building project will input information? Or will it be that the architect will still have a model, and the engineer will still have a model, and the general contractor will still have a model, and that they'll basically still print out the pieces of paper and share those legally? Now, this great debate, and that was their term for it, not mine, this great debate pitted two of the biggest software vendors against one another. So these visions were not, these weren't simply, speculative, and they certainly weren't some silly little debate. It was literally, what is the information management system structure going to be for going forward with billions of dollars of investment? And the third was, when we started our first interviews in 2008, everyone said, well, BIM is a great idea, but the challenge is, you're going to really need to fix those contracts before we can do anything about it. So, already the kind of challenge of what this technology would face in terms of its adoption was already part of how people talked about it. And we make the argument in the book that the way people talk about the technology prefigures and sets up how people in the field will begin to work with it and around it. So, these are just some of the most recent ways that we can see the kind of how industry leaders make this future, the kind of futuring work they do. They talk about it through conferences, through trainings, through Autodesk University, through a national BIM forum, through national BIM standards, through the Building Smart Alliance, etc. So there are lots of different actors and agencies kind of talking about and putting forward a vision of what this thing will be. Here's a very early slide. This is from 2006, just before we started our field work, and it's from one of these key players in the space. The Building Smart US Alliance put forward a vision of who would use and control information making up these BIM models. So this DNA looking thing, the information backbone, would simply be, we would add knowledge over time, and that information backbone would be how we would come to know what we might now call the digital twin of a building. If you see on the right hand side, you see these information exchanges. So you see vendor and project team, you see everyone, they're just plugging in, right? And the arrows go both ways, but it's just as simple as that. A particular vendor or a particular project team, shown here in their own color, they take their knowledge and they plug it into the information backbone. Now, we can sort of see these phases: the building's conceived, planned, designed, built, operate, renovated, disposed of. We can just do it through this information backbone. And this is a very centralized vision. There would be one single shared model. And what this is. So this led to the great debate, whether or not we would have a centralized or federated database. The idea, oh, sorry, I need to do this. These were set up by two competing makers of BIM software, and Bentley puts their cards on the table. We believe that starting over with a new incompatible platform, as Autodesk suggests with Rivet, in order to achieve these goals is dangerous, wrong, and wholly unnecessary. I mean, let's not mince words. The way they're building software over there is dangerous, right? Nothing short of that. And the way they're building software over there is that kind of centralized information space that I just showed you, right? So that information backbone model, according to the folks at Bentley and the makers of Navisworks, that's a dangerous way. And they do mean dangerous. They do mean that it would be dangerous to build in that kind of environment. And so this great debate shows us the tension, that these kind of visions of the future don't just magically happen, right? They are crafted, negotiated, debated, and often hotly so, as it was with this. In the end, the industry goes with something that looks a lot more like the Bentley white paper, but not because I think they won, so-called won the great debate. Let me explain a little further. We're going to see that in this next phase of negotiating practices. Now, by negotiating practices, we're talking about all of that work that has to be done on the ground to make the new technology fit into existing work practices. Those work practices don't change overnight. Recall moving how we saw people putting plans and specifications on light boxes. You know, they stood around and they watched and they thought through those documents together. They're still needing to do that work. They just now, you know, need to figure out how to do that and make it smooth. So these are the negotiations around new digital tools that address the challenges and conflicts that mattered for how people do their jobs. So these are very much on the level of the work practice. And the examples that we see in our field research are really these new emerging team structures and leadership experimentation that help the teams explore how they're going to do the things that they're required to do to get a building built, and do it through and with this new technology. It leads to a whole host of new informal collaboration practices, and that there are these new team capacities in the face of more and rigid and slower moving social institutional constraints like contracts. So they couldn't change how the forms of the contract took place, but they could figure out how to work around those. So it's a process of working around. And so we see here, this is a picture from one of our field sites. This would have been one of the first times that this kind of visualization was used in a construction project in the United States. So it's not the first, but it is in a city that was a leader for its field, a leader in the US, and for a construction company, this was their first major experimentation. So, you know, this is quite radical. How are we going to actually get people to identify and solve some of these problems that we can once we build this digital model with all the systems in it. I want to be mindful. I'm just going to move my controls here so I can see here. So one of the challenges that we have in the kinds of work that happens in construction, particularly in the sliver of MEP coordination that we focused on for a 3-year project, is that there are these conflicting obligations to the particular scope of work, someone's professional orientation, the particular project that they face, or the particular affiliations to the subcontracting or specific companies that they work for. And so most people have to move across each of these three quite fluidly. Those charged with making these digital models for their company, they often have a very close affiliation to their scope of work. So a plumber, say, someone from a plumbing subcontractor, has to know plumbing building codes and be really oriented to that. If we think about the general contractor, the staff for the general contractor are charged with delivering the project, right? They tend to be the ones who, while they're paying attention to all of these obligations, they really are focused more on what is best for the project. And then with each particular company, they're needing to think about what's in their company's best interest. And these orientations and obligations come into conflict quite a bit. And so these conflicting obligations really end up shaping the collaboration approach that different actors have as they follow through with this. So detailers couldn't quite understand, if we come to the bottom row, why they couldn't simply get the information they needed to get their job done, and several kinds of challenges that we see there. In terms of the project, with an orientation to the project, that collaboration approach is, let's simply, we've got problems to solve, and let's come up and use what's best for the project as the ruler. And then time and again, we were hearing, people talking about their company's exposure in various decisions. And so these kind of conflicting obligations show us that there is a tension between this ability or affordance for exchanging information and the risk exposures at hand. We'll come back to this. You'll see this. This isn't the last time you'll see this in this short talk. So here's what we're talking about in terms of these federating models that we have. Different kinds of scopes of work. This red will represent, for example, a fire safety system, and this blue will represent an air handling system. Different scopes of work are designed by subcontractors, and then with the general contractor and their staff, they bring these files together. So, imagine working with your collaborators in a shared Google document. You might take some work offline to fix it, and then bring those pieces together into a shared document to see how they fit together. That's the model. That's the model here. That's how this is going. There we go. Right. So what we saw in our first case was that we had a very isolated team. They needed, for this incredibly tightly coordinated project on Hill Hospital, they needed a model from the structural engineer. These subcontractors and the general contractor project engineer were all in a team together, but the structural engineer had long finished their work, and so they couldn't get the model for the structural steel, which they needed in order to be able to make sure that the pieces all fit together. So they were in fact being asked to do the impossible. Ensure that your pieces all fit together, but we're actually not going to give you the important part of the jigsaw puzzle, the steel beams that your system has to fit around. We're not going to allow you to see where those are. The reason they weren't allowed is because of some of those risk exposure problems. And so they had to reconfigure their practices. They had to go through a process of discovery, figuring out what works through trial and error, and often in quite informal ways, often asking people to put aside their concerns about risk exposures on the contract. They really struggled to get the technology to work, particularly in those early BIM projects. And they were struggling to get alignment, both cultural and leadership alignment, around these new emerging practices. Again, they were asking people to work in wholly new ways to make the technology fit. So they were having to adapt to the new technology. And then finally, they enter a process of reconfiguring those practices around the constraints that they could see. So there were, just like there are steel beams you can't get around, there were some legal and contractual obligations that they simply couldn't figure out how to work around. But they were figuring out what the technology can do, but simultaneously also figuring out what the teams could do around that. So that brings us to the kind of final and, I think the big and often forgotten point about technological change and disruption, which is the process of rewriting those institutions. How do we rewrite the institutional rules of the games, the social institutional rules of the game that companies and industries work under? We talk about this as the work of resisting or revising the institutional constraints that people, teams, and companies face in using those new digital tools. And the examples that we see in the three cases that we followed very closely were, there was some experimentation with new styles of contracts. And in fact, we see a lot of excitement and enthusiasm in the building trades around integrated project delivery, a completely new kind of contract that helps teams take advantage of the technological affordances of BIM. We do see one failure from one side of the great debate, the idea that you're going to have a single industry actor who owns that information backbone. That's just gone. That idea is not going to fly. But we do see a success for one sliver of the process, this MEP process that I talked about, the subcontractors, because they work under one unified contract for the general contractor. It's almost like there's a little, a little innovation hub happening around the general contractors, around how information sharing can happen. That's in part because they were able to experiment and negotiate around that risk exposure that architects, engineers, and builders simply couldn't figure out yet how to do that. And finally, we are seeing some owner-led innovation. So one of the largest builders, one of the largest buyers of building services in the United States is the US government's General Services Agency. And they are pushing for incredible innovation in how you think about the sociological and socio-technical and organizational challenges happening in this space. So going back to our isolated team and this conflicting obligations model that I promised I'd bring back to you, the isolated team on Hill Hospital, that simply, they understood how tightly coupled their work was and how distant they were from the rest of the building project. They said simply, sometimes you want to be able just to talk to the people who know what you're talking about. They really retreated to their own scope. They really defended their company positions. And it was hard to get the people working on that MEP coordination to really come and see the interests of the project first. On the more integrated teams that we saw in particularly Lakeside Labs, this question of working towards the project and having that value as helping to shape what they did, they really worked to align those obligations that they had, and they really championed the project. So people working on that project were able to really, as Lance says, do the right thing for the project. They were able to figure out how to manage the risks to the company and how to manage the work, the obligation to the scope, vis-a-vis the values of the project. And so if we were to think about what this means for rewriting institutions, I would say with technological change, we have these industry, company, or project and team level changes that have to happen in terms of the social organizational constraints, those social institutions, the laws, regulations, contracts, etc., standards of practice, codes of work that have to happen. In our particular case, we see new kinds of delivery methods, new kinds of teaming, and new kinds of individual work practices emerge in light of how these kind of institutional constraints are still in place. So there's some pushing back, right, from the agents to the structure. There's some pushing back on those institutional constraints. Finally, this leads us to thinking through what it means, technological disruption through negotiated adoption. How do we think about work that happens on network scale and on geographic scale through these three processes of futuring work, reconfiguring practice, and rewriting institutions? And so with that, let me just make a couple of grand gestures. I think if we're thinking about mapping big technological changes that we know, this is what Digit does, this is the work that we as scholars do. I think one of the important things, one of the charges that I leave all of you with is the real urgency to recognize the work of making futures, that when we think about a future of work, we really need to understand there's so much that is happening simply to make these technologies thinkable and possible on the practice level. And I fear that we're missing some of that out. I think we need to build in support for how people negotiate those new practices around technologies. And again, our adoption stories are often jump over that step. And when we spend time in the field really focusing on how and what people are doing with it, we see their frustrations in terms of how the technologies aren't quite allowing them to do what they're promised through all these wonderful visions. And then finally, we have to understand that these social institutional contractual rules, the laws, regulations, contracts, aren't there to support how people are working with these new technologies. They're often quite frustrated in the gap between what they know they should do, legally are obligated to do, and what this technology is kind of pushing them to do. And they're getting two pretty mixed messages. And so I would argue we need to pay very close attention to how those big changes in the rules of the game come about. I have taken so much time. I just want to make a plug. I have a new book out on human-centered data science. Happy to answer questions about that. And I will, as I start to turn down my slides, leave you just with a bit of what we're doing at the Minderoo Center for Technology and Democracy, taking on some of these really good questions. So with that, I'm going to stop my screen share. I'm going to thank all of you for your time. And I see some questions wonderfully in the chat. Shall I take questions in the chat in our time together?
Yeah, I think Fran's turned all the videos off, or certainly my videos off. So so I can't see if anybody's hands in the air and anybody would like to ask a question, but maybe we could deal with Jamie's question first. How important do you think the quality of data is in the first place?
Yeah, so I think it's twofold. On this first project, it was incredibly frustrating for the Hill Hospital MEP coordination team to be working in these incredibly tight affordances is the word that's coming to mind, but that's socio-technical. These allowances, these very tight allowances, right? Millimeters, literally millimeters to spare within this ceiling plenum where they were trying to coordinate the work, and not knowing where steel beams were running through their work. It took them months of negotiation. It took them so much time, and they never were able to get the digital model from the structural steel engineer that they knew existed.
Yep.
So for them, that data quality is absolutely important. But flip it to the point of view of the architect, right? The architect is legally, in the United States, is legally the one responsible
Okay.
for the building quality, the information quality. And so that really becomes kind of one of the key things holding this whole system back, right? We can't, until those rules of the game are changed, where the architect has some legal protection, they are responsible if there is a mistake when the structural steel model gets shared with the contractor. So, yeah, I do think the construction industry is doing the best they can, but I think the expectations were set pretty high for how this transformation would happen. Why do you consider it dangerous, or is it security, privacy, ethical issues? Right, Roger. They considered it dangerous because the architect would not be signing off on these documents, right? That the kind of institutional configuration of who verifies these are accurate documents got challenged by the idea that they would have a single information space. Oh, can we get the video back, please? Oh, yes. Can people put hands up? Yes.
Sorry, I'm attempting to get the video back for people so that I can see if hands have gone up in the air. Yes. Otherwise, we just need to have a shout out. Would anybody like to ask Gina a question? Ah, Simon, yeah.
If there's someone else, they're welcome to go. But I thought.
Oh, I can't see. I can't
right,
see.
that's fine. I was just wondering, because it's quite interesting to look at your context, you know, in construction and the tools that are there. And I mean, how fit for purpose do you think their tools are, and which way round is it? Is it sort of? I know that's a very loose question, but
no, it's great. I think it is the question, right? It is the question. So for audiences like this, I often liken what they've done to Adobe Acrobat, right? Yeah. So what Adobe allows us to do is to take all kinds of file formats and put them together in one document, right? It doesn't matter whether it's a Word doc or an RTF or a JPEG. You can put them all together and it can publish it in a PDF, right? It can read and translate among many different file formats. And that, in essence, is what building information modeling does. It allows for all of those CAD tools that have been built, custom built for the particular discipline. So plumbing systems, mechanical engineering systems, architectural systems, building planning systems, all of those different file outputs can be translated through the BIM software, right? That's in essence, that's the big innovation. And so now, you know, we're having a system where do you throw the baby out with the bathwater and say, if we were starting this thing from scratch, would we build it differently? And that's exactly what Autodesk did. Autodesk said, you know, we build many of these individual packages. We, as the industry leader, we can throw the baby out with the bathwater and start afresh and build something that we think is better. And they run smack into this challenge of nobody being able to figure out how they might integrate this into the existing constraints they face. Those conflicting obligations on the project level, but then those big social institutional constraints of how the contracts function and who is legally responsible for the information. And so that's ultimately, you know, it's not a technological problem, what's fit for purpose. It's okay, it's a human-centered design problem on an industrial level scale. And I think this is one of the challenges that we really see with when we talk about technological change and disruption. We see these, you know, you can solve that one problem, but there's this process of futuring work, of negotiating practices, and then rewriting the institutional rules of the game that a tool has to go through. It has to go through that process of adoption. Does that make sense?
That makes sense. I guess in that example is also a technical challenge, which is the interoperability challenge.
Yeah.
Absolutely. And I think it's not, you know, let's applaud. I forget often to applaud the industry for that interoperability challenge, right? The software, the construction trades software options have solved that interoperability challenge.
Yeah.
It was a socio-technical interoperability challenge that was much bigger to solve.
Thank you.
Okay, anybody else here? Anybody else want to ask a question? If so, putting hands up will be a good idea.
This has been really great to be able to.
Yeah, it's these things are so much more interactive, aren't they? Once they're face to face, it's much more difficult when it's sort of in a Zoom type environment.
Well, it's a very good excuse to come in for a day that is not a real strike day.
Yeah. Can I ask? One thing that occurred to me as I was listening to you, integrated project teams have been around a while in defence, and you know, so I'm aware that most large defence contracts in the last sort of 10 years have had IPTs, and they've had mixed success. I wonder whether or not you've been able to tap into any of that literature. I know it's a different literature, but they're projects, so there must be an analogue here.
Yes, there is, and there is quite a bit. To be fair, there is quite a bit of experimentation going on integrated projects and integrated project delivery. The challenge is that change on this is quite slow, in part because many contracting scenarios, the actors' hands are tied. Yeah. So in defense, you have a client, a very, very big customer, right? You typically are in defense, you're contracting for the government, and you have very few numbers of players who can provide those services. But when you're talking about a real estate developer and you're looking at a plumbing subcontractor, you have many, it's many more pieces. There are some ways, and you're absolutely right, Roger, that there are, just throwing up and saying if the teams came together this would solve all the problems isn't quite it. I do think we have those big challenges of figuring out how to renegotiate those work practices around a new technology, and then figure out which rules of the game need to be changed.
Okay. Any more? I am aware it's 27 minutes past, and we said we stop at 1:30. One last question, if anybody wants to ask. Otherwise, Chong, I think is that a hand in the air? Oh no, that's my cursor. Sorry. I'll take that.
On a warm day, I don't regret ceding 3 minutes back before your next calls.
Yeah. So I'm going to say thank you very much, Gina. We've really appreciated it. It's been extremely interesting. Lots to take forward for Digit Lab. And we're going to have a break now. Just speak very briefly, we're going to have a break, but we're going to start again in September. So for those of you monitoring the email and the newsletter we send around, we should be starting again in September with sessions in September, October, November. So thank you again, Gina. Thanks very much indeed. And we appreciate you joining us. Thank you.
Thank you. Thank you so much. Thank you.
Bye-bye.